Hello and welcome to the inaugural East Bay Rust meetup. My name is Yerke Tulbergenov and I'm an engineer here at Block, and I'll be your host tonight. So today's event is sponsored by Block and Z Industries. Block graciously provided us with this location, and Z Industries sponsored the food and beverages. I would like to, yeah, thanks. So yeah, if you can clap better so I can then put it on my prom packet, it would be great. I wanted to give a special thank you to all the folks who helped organize this event. So all the folks who helped to register here, get you to the restroom, get you food, and all that other stuff. So I'm gonna mess it up right now because I'm gonna try to tell the names from my memory, but that includes Mikayla, Rain, Tosif, Mary, Ray, we even made one of the speakers hold the door for you, so please be grateful. He's the founder of the company. So yeah, I apologize if I forgot to mention anyone here. Oh, actually, Jenna also then helped us out, so thank you to Jenna. And then big thank you to Esther, who was not able to come in person today because she's in France, but without her, we wouldn't have been able to organize this event. So Esther, I think you'll be watching this afterwards, so thank you a lot, much appreciated. All right, so tonight we will have 4 wonderful speakers who will be telling us about how they use Rust in their projects. If you are interested in giving talks in the future events, please reach out to one of the organizers. Thank you. So without the further ado, our first talk will be by Jonathan Kelley, who will be telling us about the Dioxus framework. Please welcome Jonathan.
Oh, hello. Hello. Hey, I have 2 microphones now. How's it going? How's everybody doing? Let me make sure we can share. And, taking a second. Okay, the side ones are updating, but the main one is not. Is that? Show my screen anyway. Oh, it only does the sides? Oh, okay. All right. I'm still learning. Okay, so my name's Jonathan Kelley. You might have heard of me for some of the work on Dioxus. Today's presentation is actually not about Dioxus, but there is a small tangent about Dioxus in there. I don't know, people are still interested, but we have a new project. It's not open source, sorry. It's our first closed source project. It's called SkyVM. It is entirely built in Rust, front end, back end, worker nodes, infrastructure layer, like everything in Rust. I don't know how many projects like this exist, so I hope you guys find it very interesting and very exciting. Hopefully you can see the sides. Yeah, so SkyVM is our new tool. Hopefully you saw it on the internet. We did a little launch that lets you instantly start snapshot in share cloud virtual machines. We built this for Dioxus, which hopefully you have seen before. I don't know, you're here at the Rust conference. We're like a little popular of a Rust UI framework. There's not many Rust UI frameworks out there. Well, there's a lot of them, but not that many like actively maintained, very exciting ones. So we let you build web, desktop, and mobile apps with your one Rust code base. This is kind of a rare skill for programming languages. JavaScript, TypeScript are kind of the only languages that really let you do this at the moment, other than Rust. But Rust and its like really fantastic WASM toolchain lets you compile your apps to WebAssembly that then runs in the browser. So we're very nascent. This technology has been around for like several years now, I think like 6, 7 years now. But the tool chains have improved. We have actually pushed the tooling forward in many, many ways, making this easier and more capable. And then also mobile. Very few people are building mobile apps in Rust. I think we're pushing the frontier. Our goal, our dream is you write your app once in Rust and it compiles to all of the platforms and it runs native widgets. So not just like painting its own pixels and like there's no native elements. We want like full IME, emojis, all the languages. Like on an iPhone, if you like press and hold on a widget, it feels like a native widget. So that's what we're shooting for, all in Rust. We built this. The slide's not updating. Okay. Well, okay, there you go. Okay. We built this to solve a very specific problem. So it wasn't like, I'm excited about Rust and like, let's go build a Rust thing. It was a very specific problem that as companies grow, and you might be at a company right now that is growing, you start to have many product surfaces. You start to have a desktop app and a web app and a mobile app, and you have to start using all these different technologies to build everything on all the different platforms. It's very tedious, it's very painful, and if you have a small team, it's very challenging to maintain all the product surfaces. Basically, to compete with some of your larger competitors, you need to go raise more money, hire more engineers. For example, like OpenAI, Anthropic, they shipped Claude Cowork and their like Codex app. Those like still don't have like Windows and Linux implementations of those apps. So they're using Electron, which is a cross-platform app framework, and they still just ship for Mac, and they just ship for Arch64 Mac. So it's like what are we doing? We have all this technology at our fingertips, and yet we're still shipping. I don't want to say slop, but like we could do better. We could do much better. So that's why I built Dioxus. It is supposed to look like React. Sorry. It is more like solid.js these days. It started pure React, and then like I didn't realize people hated React when I first made it. So like it's like a painful process to move more towards like signals, like automatic reactivity. But like the bonus of it being React-like is the AI models will like write it for you because they've seen React and they're like, I can just do that in Rust. I did not know that going into this project, but like fantastic that it worked out. I think we have like an agents.md file that ships with Dioxus. You can just like tell it to build an app and it will go do it and it will be exactly the same as React, amazingly. So I'd say it's like a competitive advantage in the new world where you don't want to write all your UI code by hand. We've done a lot outside of just like what does it mean to like make components and put them on the screen. Like that asset call, that is not embedding the CSS in the bundle. If you like actually build complex bundlers, you want to version your assets, you want to fingerprint them, so you want to do cache busting, you want to be able to roll it to CDNs. What that is doing is actually encoding an empty spot in the binary, and then after the binary has been built, we go fill that empty spot in with like the actual link to the URL. So there's a whole world of technology powering, like it looks simple, it's not simple under the hood, but it feels simple when you use it. And there's even crazy stuff like use signal here is it's a copy type that's not normal, that we've built this crate called generational box to give you Swift like garbage collection, but not garbage collection in Rust. So there's a lot that goes into it. We have renderers, we have the whole 9 yards. Our goal is to shrink like the size of the project and the complexity. So normally you would have like a gazillion files to do an app with us. It's very simple. So there is like a legit trade-off. I'm not just super excited about Rust, but I am excited about Rust. But like, you know, there's more to this than just like being super Rust-pilled. Our tooling lets us build for all the different platforms. There's an experimental Harmony OS renderer for like the Huawei type phones. But broadly, you can do web apps with WebAssembly. You can do desktops. So that's Mac OS, of course, Windows and Linux and all the flavors of Linux. So we support like the different window managers and stuff. Linux is a fun place. Android and iOS, very few tools in the Rust ecosystem have any form of like mobile support. Dioxus is the only, or the DX CLI is the only tool that is like, you can like serve with hot reloading a Rust app on an iOS device. And that is just like not a thing that anyone else has or does. I wish it got a little bit more attention. We don't really do a lot of advertising. We're going to spin out the CLI itself to be just a more generic, like Cargo++ tool soon in the future. But these are the features you kind of get with Dioxus. One challenge here: our team is 3 people. The span of work is like immense and frankly infinite. Sometimes you hire people for your team literally because they develop on a Windows machine. Like sometimes that is a job requirement, and we want to lift that requirement. There's only 3 of us, and there's like more platforms than we can hire people to develop for, or we could hire more people, but so we wanted to build a platform that actually makes it easy to do all of this native app development, not necessarily on our machines. Normally you'd open VMware or Parallels or the UTM. There's all these different platforms. If you've done VMs, it's a pain in the ass. It's terrible. So we wanted to build a platform for Dioxus, in Dioxus, that lets us do fast iteration on both our tools and for users to be able to, like go build the iOS extension to their app, even if they don't have Xcode and all these things installed. Or like what we were using it for is like, we have tweaked something in how like the build system works for iOS, and you can open a PR with a link in the PR. When you click on it, it takes you to a Mac virtual machine with the simulator running, and you can test your changes. So like normally you would like pull all your code, Xcode build, sit around for like 10 minutes, go get some coffee, browse Twitter. Now you just click the link, you review the code. That's it. So cool product. Before we jump into that product, there's 2 cool Dioxus updates that shipped recently. This is not a Dioxus talk, I swear, but one of them is our hot patching engine, which is, I mentioned earlier, you can edit Rust code on the fly. We do binary magic. We do a lot of, we're down at the linker, down at the compiler level, kind of doing things in an unusual way, but you can modify Rust code on the fly and updates in like a fraction of a second. So we added a workspace support to this recently. I don't know if you followed this project, but you can edit any crate in your workspace, and now the changes propagate to the running app. So if you have like a shared like API between your front end and your back end, they no longer have to be part of the same crate. They can be like spread out all over on your file system. So cool update. People were excited by it. That was one thing that we shipped. Another thing was a general FFI system. There's not a great there's great ways of exporting Rust into other languages, but there's not great ways of pulling other languages into Rust. So we shipped that. So you can link directly into Kotlin, iOS, or Swift, Objective-C, and then you can do crazy things like live activities on iOS. So I think we're like the first person to or first people to do like, I have a Rust iOS app, and I'm going to go do a live activity, which is like the little ticker on the home screen that's like, what's the score of the game? You can do that in Rust now. That was AI assisted a little bit to figure out how all that works at the lower level, but it's very cool. So, and like what this looks like in practice is also very cool. You just annotate an extern block with some FFI thing, and then like it links into all the files. Our frame rate is terrible at the moment because we are doing this streaming thing. But yes, very cool. So SkyVM. This is the tool we wanted to build Dioxus. And also maybe it will help fund Dioxus in the future. So this is also an ad. Whenever the product is out and live, you can pay for it, and then you can do this sort of cross-platform app dev. It's not exclusive to Dioxus. It's very useful when paired with Dioxus, but the idea is that anyone building native apps or mobile apps can use the tool and like rapidly enhance their development speed. The frame rate is terrible. This is so sad. They're instant boot cloud VMs. So here, I'll click on the thing. Within like half a second, you can click the launch button. Wow, this is not great. And a VM is up. You can configure the VM. So like, if you've ever used vSphere, VMware vSphere, it's an expensive product made by a company that like people are like turning off of, but there's like basically no good alternative. There is a button to click and you get a VM, but usually it goes through the very long boot sequence, and it has to go through the bootloader and all these things. We do memory snapshots of the VM, so there's some like low-level Rust code. When you do this at a distributed scale, it gets very challenging. So there's like network block driver adapters written in Rust that we like load into the system, and then we also do like something called block diffing. So you want to do like a live migration, you want to do it copy on write. You're going to have to write that in Rust. So we have a thing called block diff. Well, like operates at the file system layer. But what it gives you is the ability to like you press a button and then you like on the file system you fork both the memory and the file system of the virtual machine, like a base virtual machine, so like a development virtual machine you've primed, and you immediately get a new one. There's no waiting. If you've ever used any other VM tool, you sit there and wait and you wait, you wait. It's terrible. It's not like that with our stuff. Our goal is the deploy previews for native apps. If Dioxus deploy was ever a thing that anyone paid for, they would probably want to preview their native apps in their PRs. So that's what this provides. You have a URL, you can click on it, and then immediately you're in a VM. So this is a macOS VM that kind of gets launched on the fly in this case. So Mac also lets you do this like fancy memory snapshot resume magic. I don't know how you guys feel about AI. I don't know. Raise your hands if you're like pro coding tools. Okay, this is a Bay Area sampling. I like this. Okay, all right. There's an embedded Claude code in the thing. So there's like this little sidebar. It has access to all of the tools in the VM. It has access to spawn other VMs. It can do subtasks. We use the rig library, which they don't have like an agents.md, so I went and made Claude go generate one, and then I use that to go build this. So it's all very self-recursive, but it's very cool. So there's a Rust library that lets you like do agnostic tool calling, create little agents and stuff. So we have the Claude Agent SDK powering the whole thing. You can chat with it from your Discord and your Slack. So you kind of have a Claude code in a VM that you can like chat with. I built this, and I didn't realize many other people were going to start building this at the same time. So there are a lot of these right now. But we're the only one that supports like Windows and Mac OS, which is like more tailored to Dioxus land. Yeah, you can do mobile dev also. This is important for us. I don't know how important this is for you guys, but it's very nice to not have to do the whole, like literally open Xcode, git pull, do the whole checkout, fight with the compiler. It's slow, it's terrible. You have deploy previews of iOS apps. This is huge for us. I hope this is huge for other people. You can do instant snapshots. So the VM is running. This is where all the special Rust magic, copy on write, QEMU features, read the manual basically, gives you, while the VM is running, you can click the snapshot button. The mouse will move at some point. Okay, well, we saw 3 frames of it, but yeah, while the VM is running, you can press snapshot. Immediately, we save the state, we serialize the state of everything, and then we create like a shareable URL out of that. So say you like, one of the things we do is like we accidentally blow up Windows machines very frequently. So you kind of want like a hermetic environment that you can go blow up Windows machines on accident, but on purpose. And then being able to go back and forth between the state before you blow up the machine and after the machine is very nice. So before we go and run stuff that's like messing with the Windows registry, we'll like snapshot the VM, go do all of our like modifications, and then we can just roll back to our save state, which is very cool. Yeah, you saw that. Oh yeah, I was gonna make this like the integrated, we have cool AI agents. There's more to the product, but I don't know where I am on time. We're good on time? Okay. Here, maybe it's, oh God, it's still so slow. I have since tweaked it to make it look more like the Codex app that OpenAI shipped. I actually kind of like the layout. So, if anyone's at OpenAI and wants to explore collaborations with Dioxus, that'd be exciting. We have some VMs primed, so you can just like click on some of the VMs from the quick launch menu, or we can say open deb VM. Originally, this was a developer tool, and now this is like, well, there's a million AI coding tools, and one of them will win. So we hope to be one of the few that might win. Yeah, so you open it, spawns a VM for you. It's immediate. We have like the VM over here. We can open a terminal. Xterm, I don't know, you guys have probably seen this. There's a couple cool features that, like, this is why I'm doing a live demo before I take up all my time. one of the cool things, so we have a VS Code instance. We can actually click open in VS Code, and it will ask to open in VS Code. And we get a remote tunnel from the running VM into our local VS Code instance. So we have to, sorry, okay, yeah. We don't have many frames to show, but John K. And then, yeah, some of the paths are wrong. It's a development thing. But what's very cool is we can, yes, okay, Copilot has issues with this version of VCode, fine. Yeah, give it a second, you'll see. You have a literal tunnel from a running VM into your local VS Code editor, which is very cool. So what we do a lot is remote dev on machines with architectures we don't have, and you want your language server to work. This makes that work. I have not used a tool that lets you do that. You want to be able to target Arch Linux 64. You have a config block. You don't have linker flags. You're not using cargo zig build, or you're doing something crazy. This lets you remote dev on a machine that matches the architecture that you're developing for, which kind of solves the cross-platform build problem in a way. Kind of doesn't. There's a million other features. I think I've run out of time. But yeah, so it's all in Rust. It's all in Dioxus. It's not open source, sorry, but to expand your mind on what is possible with Rust and all of the tools now, you can literally build a front-end to back-end distributed infrastructure. You can write your cloud management stuff. You can write stuff on Amazon, all in Rust. And the AI agents will get you pretty far there, too. So that's it. Thank you.
All right, folks, we have time for some questions, so please raise hands. I'm gonna bring you a mic, and then you have to speak into the mic, okay?
Hello. So quick question about macOS VMs. I understand that in order to host a macOS VM, you need macOS hardware. I was wondering what your provider was for that?
There's a server rack in my office with a couple Mac Minis and a Mac Studio. So yeah, that's the plan. Hosting hardware, I think, is kind of the only option. If you break the terms of service, you can get around it, but and not on the M1s and the M series, only on the x86 boxes. But yeah, so we host our hardware. It also means it's cheaper in the long run if you know what you're doing. Yeah.
And a question over here. You said that you're using QEMU?
Yes, for Linux and Windows, QEMU, yeah.
Okay. And then the hypervisor Mac SDK or whatever they call it, I forgot.
Yeah, the one built into macOS for Mac.
Are you using any of the Rust VMM crates? There's a repo or there's an org on GitHub that has a bunch of Virt.io devices and the implementation stuff like that. I don't know if you.
We have explored a faster VNC system with the Rust VMM crates, but we haven't productionized any of it yet. Okay. One of the things you'll notice when you use it is VNC is kind of slow by default, so you need a virtual display. So we've got a bunch of stuff working for Mac, and then Windows and Linux are their own can of worms. But in those, you want to do custom drivers, and then that means you have to do custom builds of QEMU and Virt drivers and stuff. So we're experimented, but haven't used it yet.
Yeah, and then I see there's that, whatever you call it, the horizontal tab on the actual display of the VM, that the thing that you can hit over there, the gray box. I forgot what it. If you click there's a gray box next to the folder icon on Ubuntu. I forgot what they.
This thing?
Yeah.
This is for no VNC, yeah.
Yeah, I hate no VNC.
Yeah, it's terrible. Yeah. Claude will rewrite it for me soon enough.
Yeah. Please.
Yeah.
Product.
All right, next question. Let me do over there.
This may not be a concern yet. I'm wondering about randomization. If you're snapshotting a VM, I mean, people shouldn't be generating host keys from the same state afterwards, but I'm reminded of the Debian bug where.
Yes, so this is one of those things. If you do a memory snapshot, your entropy matches that of the original VM. There are QEMU extensions and stuff that fix this to an extent, but if you have a Python process that sees its RNG and then you snapshot it, you have broken SSL. So if you're working from snapshots, like if you're provisioning from one of our quick launch snapshots, that has no, that like the RNG is reseeded on launch. But if you're making your own snapshots and you are snapshotting like keys before, they will be cloned. So you probably shouldn't go talk to your services because other people can just like watch and then break your encryption. So kind of a power user tool in a sense. We try to make the easy case the good one, but then everything else, yeah, you kind of need to know what you're doing. Yeah.
Okay, this works. Testing 10, 1, 2, 3. Hi, Winit maintainer here. You've mentioned setting up Windows VMs, right? What's your overall experience with that? Like, how do you effectively set up a Windows VM in such a way that's not constrained by, say Microsoft licenses or hardware?
Maybe I shouldn't say. I'll click the Windows. So we have a Windows VM. So this is a memory snapshot opening. There is no please activate Windows in here. You can use it for 180 days with, you can like use one Windows VM for 180 days. If you actually go through like AWS and all these people, they make you pay extra because there's like a license pool pay per thing if you're like, so in our case, there needs to be some sort of cost. The VMs, a Mac VM is more expensive to run than a Linux VM. A Windows VM is more expensive to run than a Linux. So it's kind of built into the pricing model. I don't have a payment. I have no pricing, but it would be built into the pricing model. But you can get around the trusted platform module boot stuff for modern Windows, yeah.
Question about Dioxus, actually.
Yeah.
So we had challenge. So I worked with React Native in the past, and we ran into problems when we had to do some custom components, specifically targeting the iOS and Android and so on. How is Dioxus handling such cases where, for example, not geolocation specifically, like accessing the GPU drivers and things like that? How do you handle that using in Dioxus? How does it, cross-platform when you talk about Windows, Mac OS, and the other ones?
Yes, so this is where the idea of a cross-platform UI framework falls apart, clearly. We have 2 renderers for mobile. Actually, we have 3, but the third one's a little bit like more hairy. The first one is just the web view renderer. A lot of companies are kind of pragmatic. They just want to like reuse web code and run some JavaScript here and there. A lot of apps are like this. I wouldn't say like the best Airbnb type or Instagram type apps are web view, but like if you're building a tool for your like rocket engineers to go build a rocket ship, like it doesn't matter if it's Objective-C or WebView. WebView is fine. For the fancier apps, we have something called Blitz, which is basically we wrote a browser from scratch. We yoinked the CSS engine out of Firefox, technically Servo, but then we wrapped that in WGPU, and we have a layout thing called Taffy. It's like a fully custom browser, but it lets you composite native widgets into the scene. So like on iOS, you can do like the metal textures embedded for the express idea of like, you want to do some super custom rendering and then let us do the rest of the rendering. There are gnarly details when it comes to compositors on different platforms. So how low you can go is not, there's a limit to how it has like surface flinger and all these things. There are things exposed for that, but it's not like the primary operate, yeah.
Was just curious if you have any plans on open sourcing components of SkyVM, or is maybe too early to ask, but.
We've open sourced one part of it, which is this, I don't know if anyone will care about this, but it is like important to me. It's called RPC. Hold on, RPC. I was unsatisfied with the RPC libraries in Rust, so I wanted to make a better one. This is not the most interesting part of SkyVM. Probably, we'll see where the project goes. If people want to pay for it, we probably keep it closed source. If people really want open source version, maybe we'll open source it. But we'll spin out pieces of it, and all the improvements go back into Dioxus. So RPC is like a different RPC library. Instead of like generating a client, we don't do that. You annotate a trait. You create like a macOS worker, you impl your trait. There's no funny magic here. You just impl your trait for the macOS worker. Like our macros are not involved. But what this means is like when you create a client, it's almost like an arc dyne. It dereferences to how this thing works. So it lets you do this, like it lets you do RPC without like special code generation, which I find very annoying in all the other RPC libraries. And it also lets you speak gRPC, JSON RPC, HTTP, all the different flavors. So this is one component that came out of it. This lets us do this like controller node architecture. So we have like a primary like controller backend API set of code that's running in Rust. And then we have the Mac minis. So the Mac minis will like connect to the host server, and they'll be like basically just like a form, like just a call. Like you just call functions on the Mac mini to do stuff. So this is one component that came out, but like the broader thing is not open source, and it probably won't be.
Thank you. That was a great presentation you had. I had a quick question about SkyVM. I wanted to know, in your experience, does it make suggestions on how it can improve, like how an application being tested on the VMs, like maybe like iPhones? I saw that you were running a test on the iPhone 16 Pro.
Yeah.
I wanted to know if it would make suggestions on how to improve performance for older devices. I know a lot more like customers or clients, they're not using the latest technology. Like maybe they're still using the 14 mini, or maybe like the 12 Pro or something like that. So I wanted to know if SkyVM can handle that kind of functionality.
Yeah. I think this even speaks to the broader point of like, sometimes there's a version of like, say, Google Chrome that has a CVE in it that you want to test. So it's actually quite nice to be able to like go to SkyVM, be like, I need a VM with this version of Chrome or this version of Xcode or something like that, which would normally be a pain to do locally and it'd be a pain to set up. You can kind of just like open SkyVM, go into the chat, like, I need this version of Xcode, and it will go fetch it, or like this version of the iOS SDK, and it will go like set up this VM to do that very specific task. If you're like testing a lot, you would probably pre-bake multiple of these, but just for the one-offs, it's actually quite nice. So yeah, you can do that kind of stuff. I didn't mention we have computer use tools, so like the access kit in Rust. We can speak that interface, so you can control the simulators or the VMs also like with computer use tools. So the AI models can like do queries, like content queries and ID queries and stuff. So yeah, you can, like if the phone is smaller on this VM, like the literal screen is smaller, the agent can tell you that like elements are off screen. Yeah, so.
All right, this is all the time we have for the Q&A. Now let's give a big round of applause for Jonathan. You want to start presenting? Okay, thank you. All right, so next we have Mikayla Maki from Z Industries. So let's give a round of applause for Mikayla.
Hello, thank you all for being here. Let me just finish my slide.
This is the true hacker. She's typing right on the stage.
Turns out I can use my computer more quickly than Claude. So, you know, Anthropic, you gotta get good. Alrighty, let's see. There's enough here. I have to join the Google Meet, don't I?
You have to join the Google Meet.
Let me do that right now. Also, I want to say big thank you to all of you for coming to this thing that we kind of just made happen. Like big thank you to, yeah, give yourselves a round of applause. Thank you so much. And I also want to say special thanks to Jonathan Kelley at Dioxus and all the other speakers, Block, just, oh my God, this is so cool. Now that I can think again, let me find that Google Meet link. All right.
All right, while Mikayla is doing this, can I just get a show of hands of folks who actually use Rust in this room? Can I? Yeah? Oh, nice. And then what about show of hands of people who have never tried Rust? Oh, okay. So you have the newbies, right? You see where they are? Like you can just hound them right after the meetup.
Is there a mic? The other mic? You're fine? Okay, cool. Fantastic. Let me share my screen and we can get, have I never shared my screen here? Okay. Does this work? Don't look anybody. It's gonna get a preview. Okay. Is it there? All right. Everyone can hear me? We're all good to go? Okay. We're here. Hi, everybody. I'm very glad that Dioxus and a few started this off with the VMs because I really wanted this meetup to not just be about AI, right? There's a lot going on. There's a lot of other things out there, right? But if I'm going to be real with you all, I just really want to talk about AI right now. Opus 4.5 launch was really crazy and things have been happening and oh my God. So I've been trying to think of like, how does this work? Why does this work? What am I doing now? Like, what do I have now? And then part of this is to train new people who come into Zed. Part of it is just to express this because I expect some of you are probably a little more skeptical about AIs. You maybe not haven't seen it, or we've all seen the slop and everything like that. So why is my experience different than all those other experiences? And so that's what my talk's about on programming with agents. So I was talking with a colleague too about this, and he brought up a great mental model for this. That mental model is spaghetti. I said spaghetti. There we go. Spaghetti, but not that kind, or this kind, or this other kind I'm about to show you, or this third kind, but this fourth kind that might show up in a second if we're lucky. There, Factorio. Factorio shout out. Spaghetti code. Spaghetti. This is the spaghetti I want to talk about. This is a failure mode of 3D printing. I don't do much of it myself, but I know a lot of people who do. If you get the temperature wrong, if you get the speed wrong, you get the physics wrong, this can happen. This is a thing that happens when you try to reach too far with 3D printing. And I think this is a good mental model and a good understanding to know why sometimes programming with agents is a complete mess and sometimes it's amazingly powerful. Because 3D printing is also very powerful. We can do incredible things now. So yeah, but if you're not careful, you get spaghetti. And all this comes down to so I'm saying spaghetti and 3D printing are like programming with agents. What do I mean by this? Well, it all comes down to the nature of the mind behind the agent, right? The LLM. And also this great quote I had, agents automate the typing, not the thinking, right? LLMs do not do thinking. They do pattern completion, right? That is what all the research is for. That's what all the training is for. It's to give you a very compressed representation of the next thing that's most likely in a string, right? So as an example, if you see the string hello, right? The next most likely one we know is world, right? This is it. This is everything. All the AI stuff, all of it, don't care in a minute. Just remember, it's about the most likely next token, right? Take, that's all it does. Just one word at a time, not a word, token at a time. But run that in a loop and you get that streaming output we all know from the LLM tools, right? So the thing about this, though, is that we need to talk about the nature of that word likely. Everything with agentic programming hinges on controlling probability, right? There is a space of likely next tokens. That space is dependent partially on what the labs have trained into it, and partially with the reality that we are enmeshed in, right? And when programming with agents, you need to be aware of these degrees of freedom. You need to be aware of all these different things, and you need to constrain them until only the correct code is possible, right? So as a very simple example of what I mean, right? Let's do a little exercise. Who can tell me what the next token after this is? Anyone have any idea? See, all of you are hallucinating right now. All of you are just coming up with nonsense right now, right? Same with ALM. If you ask it to complete this, it'll say something that looks like a grammatical sentence, and it might even make sense. But there's nothing to go off of, right? This is a hugely unconstrained space of possible next tokens, right? Now, I'm going to go give you another one here. What do you think the next token for this one is? This one's just one character, but I don't know about y'all, but I think we can all kind of have an expectation. Oh, is it not caught up yet? One of these days, this will work. Yes, this one. I don't know about y'all, but I can have a good guess of what the next character is, right? It is nearly 100% likely. The only ways is it's not an exclamation mark is when somebody's messing up. And so if I was to predict the next token, I think all of us, if we were doing this with good faith, would know the correct completion for this one, right? So this is it. This is the entire skill. This is the entire trick to programming with agents, right? You need to have an understanding of the degrees of freedom in your problem, right? The only thing you have access to, the only control you have is the string of characters before the next one, right? You need to use all the same tools we've already used to constrain the one that is likely, right? So this is what tools uses and agent harnesses do, right? They bring your test suite into the prompt in an automated way, right? They let your test suite be a constraint on the possible next completion, right? Other things that can be constraints, right? A strict type system. Every valid Rust program, you know, caveat, doesn't have memory issues, right? So if you can get the LLM to generate a valid Rust program, at the very least you can say, it's probably not going to crash your computer. Caveats we all know and love. You know, tests are constrained, type systems are constrained, APIs are a constraint, architecture is a constraint. All these things shrink the state of possible next tokens that can come out. And it's as engineers, we have a lot of context and a lot of understanding of this, right? This is, I think, the other big takeaway I think about a lot. If the slides would keep up with me. The craft is the same as it's always been. It's all the same stuff. The engineering is the same. The values we've had is the same. Everything we've already done is the same as it was before. Craft is the same as it's always been. The only difference is now that we have something that can do the typing for us. If you can set things up just right, you can be like, I want a test that looks like that one, that uses the setup from that one, but that checks this extra condition. And these days, that's enough to get you a whole nother test. So yeah, that's the talk on programming with agents. Just constrain the spaces, the probability space of the next tokens, and just think in those terms and find ways you can constrain it, and it'll go pretty well. Yeah, that's the talk.
All right, a huge round of applause for our probability space Michelangelo here. Are there any questions that I can bring the mic to?
I strongly agree with everything you said. So right now, the way I'm approaching it is with Claude and VS Code, and I've got a bunch of hooks, rules, plugins, skills, Claude.md set up. Ironically, I'm trying to move to Zed to use a local setup, and Zed is one of the few editors that allow first-class support for local models. I'm not finding all of those kinds of harnesses available in Zed as yet. Is there on the roadmap?
Oh, yes. Come back soon. Yeah.
Any other questions?
So I think he opened up the subject of Zed. How, so yeah.
Y'all, we have features. You can email us at hi@zed.dev, at me on Blue Sky. we can bring the feature requests in.
Yeah. I think I'll avoid my question because yeah. Shall I go ahead? Shall I?
Oh yeah, go
Okay. So the extensions, I've been looking to see what extensions you're going to give. Is there a plan to expand what we have
Yes.
in VS Code, port it over?
We're going to make a lot more extensions. They're not going to be JavaScript extensions because we're Rust. We'll be probably compiled to WASM, probably a whole bunch of other stuff. Check back after we're done with his stuff, and we'll get into
More like the marketplace with the first class support for like how Bun supports all the node libraries. Anything planned for that for the extensions from VS Code?
No idea.
Oh, okay.
As a software developer myself, I love when users give me feedback about how I'm doing such a good job. So
Hey, I love it. Like, we need to do it all. I appreciate it. We like, look, I want to earn everybody's, Zed wants to earn everyone's appreciation the old fashioned way by just being the best. We'll get there.
well, I just wanted to praise y'all for the LSP syntax highlighting of the last release, because man, I hated looking at the enum items as the same color. It was so annoying.
I appreciate it. I'll forward those to the appropriate team.
Hi, this is not a Zed feature request. I really appreciate the framing of constraining the space of what is possible for the LLM to generate. I mean, that's certainly the right way to think about it. Something that I've been thinking about is really, right now the really exciting thing is the LLMs. Like that's what we're talking about. But programming with the LLM agent, as much as the LLM actually generating the next token prediction is one aspect of it, there's all of this context management that you talked about. I think another real aspect of that is the tooling around it, basically the framework that you can give the LLM to predict the right tokens at the right time, to have the right context at the right time. I wonder if you could just say a little bit more about kind of that aspect.
Yeah. I mean, that is the one lever you have. That's the one bit of leverage you have, right? And you need to use it well. I mean, pretty much all of the stuff from the first question, like skills and all that stuff, is a way of dealing with the hard resource limits of context there. Fundamentally, right now, I think a lot of it is up in the air. Yeah, like I think honestly, I think the much more important thing than the harness is the code base and the patterns that you and your team have. Architecture documentation. We don't have much of that at Zed right now, and I keep having to re-explain it so that things get done in a new way, right? I was saying about strict type systems, right? So, I would never use an LLM to generate a Lisp language or JavaScript, because the tooling to comprehend that code base is it's the reason TypeScript exists, and it's the reason Rust exists, right? Well, not just that, but that sorts of thing. So I think context management is very important, and I think there's a lot of different actors who can do this, the agent harness, the LLM architecture, the number of tokens they accept. But at the end of the day, it comes down to the code base and the LLM, and all that stuff in the middle is kind of, 10% here, 5% there, which can be a lot, but it's those two are the dominating factors in my mind. Oh, and also your personal prompting style. I like to turn off a lot of that stuff, and I just go straight forward, just ask exactly what I want.
So I'm from the world of automotive and safety critical software where we've had requirements like all over for a long time. And there's been this sense that whatever generates your code could be fallible at any time. So you need the system to make sure it's good. And watching AI driven coding move towards like spec driven development. And we're kind of reinventing requirements and like, how do you prompt? It seems like requirements might have been a good idea as long as you're not the one who has to follow them. Like, is that where we're headed? Are we going to go back to UML diagrams and just feed them to agents?
Honestly, I don't really think it. So I'm from a startup, right? We're moving fast. We're breaking things, hopefully not very often. So I don't know that world. But the big problem at startup is that we couldn't write requirements if we wanted to, right? We're doing some big bets right now on agentic programming in Zed. And a lot of the stuff is once we'll build it, we'll know the feel for it, right? Because we're trying to build out novel UX. We're trying to understand and improve things, right? And that means we couldn't write it in a requirements if we wanted to, right? So for that safety critical thing, I think like I have a blog post that goes into a little bit more about how to operationalize this stuff on the Zed blog. But I think the fundamental thing is like all the same stuff we've done already to manage code. We just need the exact same to do the exact same thing. I review every single line of LLM generated code, every single line, every single time. And then I review it again before I hit merge pull request on my PRs, right? Because I need to know the mental model of what is happening in the code base. Every single line of code, one single exit call in the wrong place will crash your whole program, right? You need to know every single line and you need to still stay grounded in the reality you're dealing with, right? And that's not going to go away. Perhaps we will figure out a way to do code review faster, but I have found the less I try to the less I do code review, the more things spin out, the more things go poorly. So fundamentally for me, it's made my job, like most of what I'm doing at my job is the hardest parts of understanding the problem, thinking up a new solution, and then validating that solution. The intermediary parts where I have some data over here and I got to hand it here and then there and then there and then there and then it uses it over there, LM can take care of that. If I have to set up 30 billion different structs to get the state in exactly the right place, LM can do that. I need to make sure that the test it writes is correct because they're terrible at testing. And how could they be good? They don't know what good is. I'm discovering what good means as we write it. So yeah, I think requirements, they're useful for yourself. I alternate whether I just shoot from the hip or do a long plan. Depends on the subject.
Hey, great talk. So do you get a feeling of like working with LLM this way make your life more miserable? Like the idea is this, right? Like when I'm working with someone really, really good, like they know what to do, I just send one message, you go fix it in a beautiful way, write great code, you add tests, you message 5 different other people about this change, right? It feels great working with great people. If I'm working with less great people, have to work in a way similar to you said, like I have to spell out exactly what you should do. You should go change this block of code, make sure add 2 tests, right? I feel miserable, right? I feel like working with LLM is like that. Sometimes like I have to implement these constraints and you will work great. It probably is faster objectively, but in the end, like I don't get that, happiness of like building something myself, right? Like, can you relate to that to some degree?
Yeah, definitely. So just for context, last week I merged roughly 10,000 lines net changed PR. And I had help from colleagues and I did it over the last 6 weeks. And the day I merged it, I had a little bit of a breakdown because of the merge conflicts. I think the Gastown guy just had a really good blog post about the AI vampire sucking up your life force, right? I would definitely say it's harder. It's a lot harder. Like I said earlier, like the only parts of my job left are the hardest one: understanding the user, understanding the requirements, verifying that the test is testing the actual thing. Like these are all really draining and really difficult in a way that, you know, deciding, oh, is this variable IX or is it I? Like those are micro decisions you have to make, and they are exhausting, but they're a different kind. They stretch your brain in a different way than working with agents. I didn't realize how much that time was a break. Like I was talking about that wiring, the monotonous wiring between things, right? That was monotonous, and it was something that was a huge break on productivity because somebody intelligent had to do it, like as an intelligence had to do it. But it did also give me a quick breather from doing the hard evaluation. So would I say it's the most miserable? Not really though, because like at the end of the day, I've been talking about 2026 is the year of the yak shave. Like you can shave them all. Just make sure you can handle the review burden. Just go do it all. We can do it all, everybody. Every test you ever wanted to write. Literally like 10 days ago, Friday night, I just had a glass of wine and Opus, and we tested the hell out of that PR all night long. It was one of my favorite nights of 2026. Anyway, so I love tests. I love verification. I love making this stuff happen. So I'm having a good time, even if I am also overworking myself a little bit. So complicated answer. Yes, and.
Hi, Mikayla. Great talk.
Thank you.
I agree that testing saves you. I'm also in a safety critical field, and if we didn't have our CI suite, it'd be a nightmare. But that was before AI too, right?
Exactly.
One question I had, a lot of my colleagues, it's been a mixed bag. Even for myself, sometimes I don't have the success I wish I had with AI or that everybody claims to have. But how did you go about helping your coworkers have a better experience day to day with AI, trying to get them on board? Because I do see productivity gains for myself, definitely.
So it really depends, and it really it depends on the person. It depends on the project. I have found that there's a dividing line in myself, and it is whether you have considered coding to be the bottleneck, right? I have a ton of ideas. I have this side project I want to build. I have more tests I want to write. I have more features I want to write, right? The problem has always been getting my hands on the keyboard for long enough. If that's your problem, then an agent is probably the solution for you. If that's not your problem, if you're just like, I have a crap ton of a code base to read, I have no idea what's going on, don't get near that thing, you know? So this is kind of an onboarding document that got turned into a blog post right here that I was working on, right? Number one is only use agents for tasks you already know how to do, right? Hallucination management, de-slopification, you know, whatever you want to call it. This is the number one thing that happens with LLMs because they are probability machines. In fact, they make it a little more random because that actually turns out to work better than just taking the most probable thing. It's the temperature parameter. So I forget your question. How do I talk to people? It depends on what problems they have. It depends on what access to the code base they have. I know some people talk about like junior developers struggle whereas senior developers don't or whatever. I think it's honestly more familiarity with the code base. You know, I'm not the most senior developer at Zed, but I've also been at Zed the longest as an employee. And so I have an awareness and an understanding and like a feel for the code base that few others have. And I can go crazy with these things, whereas somebody much more experienced, but also newer to the company, newer to the code base, might struggle a lot more. So it depends on the problems you're having and what you're working on. Also, read this blog post and follow these 3 rules, and good luck. Try it out.
Hello. I'm in the back. I had a question.
Hello.
Okay, as a sidebar though, I just onboarded to a team. I started there a month ago. I'm already a top 3 contributor because I use plan mode with Claude. So you don't need to know a code base to be very effective with AI. But my question to you is, we're a team of 20 people working in 1 microservice, and we have over 100 PRs that are yet to be reviewed. Some of them are still in draft, some of them have like feedback, but 20 people, 100 PRs per week, or maybe every 2 weeks. We can't keep up. And then, so like I might be able to get my stuff through every day, but if you, let's say you're splitting your time, you're running the project, so you're not actually coding more than an hour per day. So you get feedback, then you don't respond to the feedback for a day. Then your PR is open for 2 weeks. Like, how do you address that issue? Because clearly the code review is now the bottleneck.
If you figure it out, let me know. Before Christmas break, Zed was trying to average around like 90, 100 open PRs. Then at Christmas break, just before Christmas break, we were like, we got to close all these PRs. And it was because it was up to 150. Oh no, and we closed them all. Come back, and it's been floating at about 300, 400 for the entirety of 2026. We have a lot of PRs. And this has also been a problem with coworkers too. Like, you know, some people are changing some things, or we're working together and they're producing more code than I can reasonably interact with. The thing is, I think code review is the bottleneck, right? Like code review is where our value is at its most present, right? This is when we check the tests. This is when we use our judgment. This is when we use, you know, our vision. And it's also synchronization, right? If I add a thing and, you know, it used to go this way and now it goes that way, everyone needs to update their mental model. You cannot slow that down. Sorry, you cannot skip that work. If you skip that work, everyone's going to follow to sync. Simon Wilson had a great article recently about cognitive debt, where it's about like, if you push too hard and you go too fast, you run out of you get out of sync with the code base, right? So it is the constraint, and it is the essential constraint. And also check back soon when we do something with the Delta DB announcement, and we're working on it too. It'll be really cool. We're working on it. We'll make it better.
So on testing and like constraining the output space of tokens, are there crates like in the Rust ecosystem that you're using now, something like property testing with quick check that you're using when you are using agents, you know, to make sure and like verify the output now?
So that's actually, I don't know if y'all have heard about this, but Anthropic recently had a big article about how they spent $20,000 of inference and generated a Linux compiler, right? A C compiler that compiles Linux. They did that by setting up a property testing system, right? They had a known good version, GCC, they had a whole test suite, and they just said, make it all pass. Caveat, caveat, right? That's a property test. There's a property the system needs to uphold when it is generating this thing. It should produce exactly this output, you know? So to your question of what crates we use all our own stuff. You know, we wrote our own UI framework. It has its own property testing improvements to it, you know, stuff for distributed systems. So, but we've also written our own versions of a lot of that stuff. So we don't really use crates. We're very not invented here at Zed. But like property testing is one of the most powerful things. If you can define a property and point an agent at it, you can spend a crap ton of tokens getting there. Caveat, that compiler had a hard time compiling hello world because it hard-coded some include paths, right? Those are the sort of problems that a human would never have because we have that logic. So even a perfect property test, like does your output match GCC, will have crazy random failure modes like that. So yeah, that's all I'm getting gesture to get off. So thank you all for your time.
All right. Thank you a lot. You want to stop presenting? Thanks a lot to Mikayla for this wonderful talk. All right, and now we have N0. So Brendan O'Brien is gonna give us a talk. I don't know the title, so piped events for the rest of us. I just read it from the screen.
It's a good place to see it.
Yeah.
Hi,
All right.
everybody.
Thanks.
Thank you. How are we all doing? Are we awake? Hi. Thank you for coming to the inaugural thing of this. I think like we all made a wonderful way through a couple of phases of entry to get here. Appreciate your patience. I'm here to talk to you about Nope, which is we'll get into. We're going to talk about some piped events today. My name's Brendan O'Brien. I go by B5 on the internet. I work at a company called Number Zero. We do networking stuff. We're mainly known for an open source library we make called IRO. IRO is a Rust project that will let you hole punch anywhere. It lets you dial keys instead of IPs, and you can use that. Oh, right. I forgot about the lag thing despite having watched the lag thing. Cool. This is IRO. And so you can use this to connect any two devices on the planet. That's not what we're going to talk about today. Today, I want to go to Imagination Land. Wow, this lag is... you're going to see a picture of a unicorn. Yeah, and it's almost like, was it worth waiting for that? Anyways, I want to go to Imagination Land, and I want to just spend some time thinking about, we kind of live in this other world where we have a whole new networking stack, and now that we've kind of, some of the themes that have been emerging around AI sort of have led us to think about questioning some fundamentals, because we can now actually question some fundamentals. We have some new tools that let us not just write tests, but explore code that we otherwise maybe wouldn't have time to explore before. And one of the fundamentals I'm going to ask you to question, I'm sure most of you can't read this. You're not missing much. It's a struct and a function that writes it to a SQL database. And the fundamental that I want to question tonight is this. Like, if we really stop and think about this, this is kind of bonkers. We're doing like string interpolation to write something to a database inside of Rust code. Like if you really just squint and think about this for a second, this is actually ridiculous that this is the way that most code runs and works. And like this gets far worse when you start to zoom out and think about what's actually happening, where we actually have like usually some abomination to the left of us called front end. There's some Rust in the middle, and then there's some SQL on the back end. Like SQL is from like 1970, right? We're dealing in algebraic grammars. And then the thing that is truly, okay, that's fine. Maybe we can just accept that each thing has its own lane. But we then really where the real problem shows up, and the one that I really want to attack is this, the slippage in the definition of these things, right? Because you end up with user in TypeScript, user in Rust, and user in a table that lives in a migration somewhere. It's just kind of, it's nice that we have the robots to do this for us, but I think there's another way. And so Nope is what we're calling Number Zero piped events, very original. But we're going to talk to you today about how events and evented systems might give us something of an escape hatch to this. And that's kind of what Nope is. A piped event, if we really sort of like in the description that we're going to use today, generally this is kind of like an append-only log structure. So under the hood, basically every time your system changes state, you're going to write down that state change. This is sometimes referred to as event sourcing. That's a specific kind of event log. You're going to use a very strong data model in this context. You're going to, in Nope, we sort of have a direct connection between a Rust struct definition and a stream. And if you change anything about that struct, you're actually going to change a stream. We also have inside of Nope composable replication. This idea that you can like just kind of add nodes and remove nodes, and that will sort of replicate naturally this set of logs. And this is going to have auth baked in from the start. Again, unicorns, rainbows, we're going to think about stuff that we probably should have been thinking about if we can redo some ideas. And so I think the part of the reason for the auth in particular is most of us nowadays, if you think about the word database, or you think about the word data, you're dealing in multi-tenant nowadays. And so this is just sort of like, okay, what if we had that everywhere? So if you squint, this kind of starts to look like mini Kafka. Kinda. Emphasis on kinda. And so what you end up with, if you get to a model like this, for those of you who haven't spent time in this world, you have your abominations, your wonderful code that you love, and then you're going to stick streams in the middle, and that's going to send data to sinks. And so now what you're going to do is your database, your SQL, is going to just be effectively a materialized view of every event that's happened at that point in time. And so if you ever needed to recreate something at a different point in time, you could replay the log, and that would turn into inserts and deletes into that database, and you would get that database at that moment in time. Can anyone guess what really big change has happened that would make restoring broken and corrupted data a really good idea recently? I'll leave, yeah. Yeah, hard drives, and definitely not the like hallucination machines that just like, yeah, hard drives. We'll go with hard drives. And so yeah, in an evented system, databases are just materialized views. And so I actually don't want to stop there today. I want to go one step further because we're in sunshine and unicorn land. And so we have TypeScript, we have our app, we have our event system. And we're going to obviously use Dioxus for our thing to replace the TypeScript abomination. We're going to write our app in Rust, and Nope is written in Rust. And so we can just have the whole world look like this now, which is a very interesting world to live in. And so this is kind of what I want to explore today a little bit. This idea that like one of the coolest things that we're seeing, I think, that I'm observing with Rust in this era 2026 of being able to iterate very quickly is the Rust compiler is giving you really good feedback for your hallucination machine. You're actually able to go a lot faster. And I think you're seeing a trend in the Rust community of exploring new and interesting stuff. And so to that end, we're going to try and, we're going to try and have Rust take off of the whole thing. And I'm going to do like a really quick demo of what that world might look like. And so let me reload this. This is going to be awful because the frame rate is really bad. But you get to see me shill everything that I just actually use day to day at work. This is Zed running Dioxus. I legitimately use both of these, not just because the people are here. But now we're going to do, I'm going to type with, here we go. There we go. All right. So this is Dioxus app. Yay. This is a recipe app. We're going to sync some recipes. We're going to just like take some stuff from CSV file and slam it into this event stream. But before I do that, I mentioned that everything is authenticated. And so I actually have to like give permission between these things. So I'm going to make the left one a coordinator. This is probably going to take a while to catch up. Oh, it's actually not so bad. Okay. And I'm going to generate an invite. Normally, you would not do this in like the real world. This is the worst UX on the planet. But this kind of gives you visibility into what's happening under the hood. And so now that the screen's caught up, we have a replication system. The thing that is kind of will warp your brain a little bit, if you spend time with Iro, this feels very natural. These two machines are just on my same computer for convenience. These could be, if I had time to get the binary to your laptop, it would just naturally function. And this could also be a box in the cloud. And so now I'm going to import 1,000 recipes. And on my screen, it looks really fast. On yours, it's going to look really painful. I worked really hard on that, but you know. But what you would have seen is 1,000 recipes being imported here, and we are actually using differential data flow under the hood to be able to do queries that include joins. I'm sure you have probably not spent a lot of time with differential data flow. It is a very slept-on piece of technology. But what we're looking at are recipes that have these numbers beside them. And so that was 1,000 recipes that were imported, but they were also categorized by tags. And this is every tag that's associated with it. Normally, you would need something like a SQL database to do that. With differential data flow wired up to a bunch of piped events, we can actually live, just based on the difference between the changes, calculate the view of this. And so this sort of metaphorically is taking the idea of reactive views and blowing it all the way through the database. And so you get this amazing property that as these events are coming in, as these new recipes are landing, this view is just receiving literally like a use view subscription that is emitting an event that is doing the smallest mutation possible to both the in-memory representation of that set and the view on the actual rendering UI. And so like just to prove to you that I'm like there's actual data here. These are all real. And we mentioned that you can do stuff that are syncs. And so both of these have independent search indexes built into them. So I can search for mushrooms. Great, here's some stuffed mushroom recipe. And on this one, I'm gonna do carrots. And what's exciting about this from the world that we live in now is if you imagine these two replicas may have independent authorization. And so you might have a different set of stuff that you can see from your friend. And so now that you have your own local search index, you have this really snappy system locally that if you've ever had to deal with the idea of multi-tenant search, it's a nightmare, right? Like this, like, how do you do it? Well, now you can just like literally take the front end, the back end, the networking code, everything being written in Rust, and you can run this, like the actual consumption on the machine is very, very, very small in terms of the memory footprint, and you can drive that all over the place. And so this is where we think like, I find this incredibly exciting from the perspective of like actually writing modern applications. If this was spread across two computers, the only computers on the planet that would have this information would be those two machines. Everything was moving through encrypted channels. And so you have a really nice, okay, I can now decide to give authorization to a different LLM. And because all of these rights are attributed, you can say, oh, those were the mutations made by that one LLM over there. And so that's kind of one of the core motivating reasons for doing this. Yeah, that's kind of the high level demo. You end up with something that looks like this, where you now have a lovely Rust stack on the front. You do not lose, you don't have to do this all in, right? You can keep your SQL, you can still back up to S3, you can still have your MongoDB, you can like, there's no reason that you have to say like, oh, we have to like completely and wholeheartedly adopt this event sourcing thing. You can still feed this all to existing stuff. But you open up this whole new dimension of things that you can do that are really exciting from the perspective of just taking stuff that used to be, you need a Kafka cluster with 5 nodes and someone has to sign a contract somewhere. And now you can just like run this on your phone and have it connect to your laptop. So hopefully you find that interesting. This is like stuff that we're exploring. We are right now doing a lot of note work from the perspective of like Kafka competitor stuff. I want to know if anyone's interested in the app stuff. If you are, we have a Discord, join it and yell at us and be like, hey, I want you to keep working on that. But yeah, that's kind of it. That's all I had to show. But yeah, I'd be happy to take any questions.
So I famously don't know how the internet works, and I'm trying to keep it that way, but this feels CRDT shaped. Is that true? Or it's a competitor, or what's the connection?
It's really hard to, so it is not a CRDT. The short answer is no, it's not. There is a leader that when you saw the word coordinator, hopefully it'll swip back, but the one on the left was the coordinator. If that one goes down, the one on the right becomes a coordinator. And so there's a leader. It uses a very lightweight coordinator model. I'm specifically not using the word consensus because what we do is that authorization group forms, you can actually just put into that, these ones have permission to be the leader. And then that's how you do DevOps in this world. You just say those nodes are allowed to run stuff. And so that matters because we specifically didn't choose a CRDT because in a CRDT, you cannot strictly serialize events. And so there are actually classes of programs that you can express with the CRDT. I'm also a little bit concerned about the throughput and a little bit concerned about the disk overhead that comes from things that are generally intended to write down every keystroke. CRDTs kick ass. They're really good for live collaboration. I don't think that they're appropriate for a high throughput database.
Great tool. I was wondering, obviously this is built on top of IRO. Are you using some of the other protocols like IRO-docs underneath, or is this something completely secondary from the existing protocols? Or like
Yeah, for others who may not know, IRO has the concept of protocols built on top of it. IRO is a kind of like a bunch of IETF standards in a trench coat. And one of them, we use the concept of the application level protocol name to do different protocols. One's for like file transfer, one's for video, audio, and one of them is called IRO-docs, which is for syncing a key value store. This would be like the kind of very mature business suit sister to Aerodox. We still think Aerodox is great. It's really good. It's just like a light permission key value store.
So what is the, oh, sorry, this delay is very confusing.
It's hard. I'm sorry.
What is the
Does that make it
persistence layer look like? Are you using any of the open source crates, something like Fial or RocksDB, or did you build your own? Is it just in memory for now?
For the persistence, yes. So tunable durability, you can do obviously just in memory. Oh no, my computer went to sleep. Then local disk, S3 is the kind of cascade, and you can decide, do I want the write to be acknowledged only after it's come back from S3? It'll be slower. We did write an implementation with Fial right out of the gates. We've been super interested in Fial for a little while. We've been using ReDB a bunch inside of our protocols. The answer is that's probably going to shift and be tunable, because lots of people need to tune it. You need to know what your definition of data loss acceptance is.
On the application side, if I wanted to make a app that is completely peer-to-peer messaging, just one phone and another phone, would this be a good tool to use?
100%. That is very much the goal. I wish I was still sharing, but there's like the source code of this. It's like 800 lines, including all of the like CSV loading. It's and so it's like it fits in 3 files, and does the peer-to-peer thing at the gates.
So you mentioned you didn't use consensus, and I was wondering, in the event like a leader fails, or like you want to be able to write some data, how do you know, like, how do you like elect a new leader, or make sure like 2 worker nodes aren't writing the same data at the same time?
This is this question is the reason I am here and love my work. You asked a distributed systems question. So what we do right now is we buffer locally, and we do not consider a write accepted until it has a virtual timestamp associated with it, which is given by a coordinator. And so basically you have effectively a back pressure tool and a bunch of ways of saying like, hey, you have rights, but they're not like rights yet. And that's kind of the way that you deal with that. And there are whole categories of what you consider a failure, and then dealing with the concerns of a net split, right? How do you actually know when you're communicating with a quorum of nodes, and how many faults do you want to accept and tolerate? I'd be happy to get into the details, but the short answer is you have to be communicating with the majority. The number of faults you can tolerate is 1 less the number of nodes that you have active at a given moment. And yeah, those are the biggies.
All right, thank you, Brendan. So big round of applause for Brendan, please.
Thanks a lot.
Okay, we now have our last speaker, Bradley Axen, who also works at Block as me, and he's gonna tell us about Goose.
So I think I'm going to awkwardly sit down because I need to pilot my laptop for this, and that stand doesn't look high enough. So let me get this set up. And I also have an almost exclusively live demo, so I'm really hoping that the Wi-Fi is going to be kind to me. Okay, so I'm going to start by showing Goose, which I hope is going to come up on the screens here. Okay, I think this is the delay happening, but okay, great. So let's see how this goes. So this is the actual Goose app running on my desktop, and if you haven't heard of Goose before, this is an AI agent. So it's yes. So that should be a little better when it catches up. Okay, so yeah, Goose is an AI agent, so it's kind of in the harness space, but I think these days when we say an agent harness, we're often thinking of the command line tools. This is also a desktop application. We've had this actually for a long time now. So Goose was a quiet open source project in the end of 2024, and then we kind of more loudly released it after we rewrote it in Rust in early 2025. And it does all the normal agent things. It comes with some example prompts that we can click on and start watching it work. And so when we first built Goose, and in February 2025, we would go and we would say, hey, could you make a game? And it would go make a game, and that was extremely impressive. I feel like that is now very boring, and you've seen this a million times. So I'm actually going to switch to something else, and maybe a game will open on my desktop while we're watching. So I'm going to start a new chat window, and I'm instead going to ask it, this is where the typing is going to get a little awkward. So I've got Goose open in its own directory here, and I'm going to ask it, can you read all of your own code? Let me set that down. Okay, so I had a couple of other live things planned, but because of the latency, I'm just going to kind of let this run. So right now we're going to have Goose go look at how it's implemented and tell us how this works under the hood. And you can see the normal tool calling thing is happening, and it's going to do a lot of parallelism as it works through this. And and then you're going to start seeing it using a command line tool called summarize. And this is one version of a multi-agent or a sub-agent approach where it's going to have one agent using this summarize tool reading all of the different code in the directory. And so over the course of maybe 30 or 40 agent sessions, we're going to read 50,000 lines of Rust, and we're going to get a summary of how Goose works. This, I think, is this demonstration, I think, is showing a couple of things that are really interesting for where I see agents going. The capability of the scale has gone up dramatically in the last even just 3 months. So what these models are, it's not necessarily that the context windows have grown, but the models have gotten so reliable at what they do that you can solve large-scale problems with recursion. And so there's a lot of tools in Goose for this. For example, sub-agents, this summarize tool is not actually part of Goose. And let me go ahead and skip to the end here and show you a little bit about how Goose works. So this takes a couple of minutes, of course, as it works through this. And we'll see another version of this that we can scroll through, where in the course of a few minutes, it can read through and explain, okay, we have a core Rust crate with an agents implementation. We have support for a lot of different providers and an implementation with a database for our sessions and things like recipes and configuration, and then a corresponding Goose CLI server, all of that stuff. And part of what I think is interesting about this is, for the Rust meetup, wanted to talk about a little bit about why we choose Rust to build an AI agent. And when we started this project, there wasn't really an ecosystem or a lot of frameworks. So someone earlier mentioned Rig, which is actually really great, and I'm pretty interested in seeing if we can have Goose go implement its provider support with Rig instead of from scratch. But we built that but we went with Rust anyways at the time because we were really concerned with portability. And so we wanted it to be easy to install Goose for any person at our company, for anyone who's going to go download it and run it across 3 different operating systems. And it's been really interesting to see how much the TypeScript models of distribution have succeeded here. So no one bats an eye at using npm to install Claude Code or whatever it is, and that's really taken off. And so this is something that I think, one second. Let me just switch to the functioning game that it created while we were waiting here. And again, I don't think that these are impressive anymore, but this always works now. Oh, it's not, sorry, it hasn't shown up yet. I'll give it a second. So I think it's going to happen. Okay, we've got my Tamagotchi game. Okay, so this is the normal agent harness thing. So back to why are we writing it in Rust? So we kind of figured out a portability problem, and then found that people were getting more and more willing to install tools with things like NPM, and didn't really need that portability argument for a while. And then now I think where it's getting really interesting to use Rust as the backend for these tools again is because you can extend the agent through, sorry, switching again one more time. Okay, so back to how we got to this summary. Under the hood here, we're using a tool called Summarize that is a small command line tool written in Rust that runs another agent under the hood. If you've seen, most agents now have this combination of skills and MCPs that give them the tool calling capabilities that they use to actually do the work. But I think what we're seeing a lot more of over time is that agents are able to just figure this out on the fly themselves. So you give an agent exactly one tool, it's a bash tool, and it can operate your entire computer. And the trick to getting more and more performance out of those tools is, I think, becoming less about, thank you, is becoming less about figuring out agent-specific integrations. You don't have to make a contribution to Goose to make it do something new. You just build a command line tool that does the thing you want it to be able to do. And as long as that command line tool has like a set of documentation in it, it will figure that out on the fly and let it tackle larger scale problems. This is really critical with existing code bases because you give it the tools you need to run your development server, you give it the tools to run tests. Things like Agent Browser, for example, have made like an enormous difference in how easy it is to build a front end with something like this. And because it can actually operate the browser, click around, and the command line version of that interface is a lot more token efficient than an MCP server in some, like something like Playwright that came before it. And so these command line tools, like building a quick summarize, I think are where Rust really excels, because you get this combination of portability and correctness that you're looking for. So every error state that the LLM might go interact with is automatically handled. And this is going to be able to run no matter where you need to take the agent to. And so this is, sorry, one second again. And so this is kind of an example of how, even though the original idea of like worrying about making sure that we could get this installed and running on Windows was one of the reasons why we chose Rust. Now that we're in the ecosystem, the more powerful part that we're finding is that you can extend it just through building more and more tools that work, more and more tools on the command line. And let me talk about one additional angle on this. When you look at the Goose architecture, the backend here is based on a lot of protocols. So to give you a few examples, the Goose front end now is starting to communicate over ACP. The Goose backend calls tools via MCP. And those protocols are, again, sorry about that. So, sorry, this, over on my side, I keep getting these pop-ups of the Tamagotchi, and it's, so let me exit out a bunch of these things. And I can't really get this to update, but that's okay. So, so I wanted to talk through the background of the Goose protocol integration. And let me switch over here. Okay. So I think, so this combination of protocols is where we actually enter into the agent tool calling loop. So if you start obviously by building providers, that's what you saw in the Goose, some of the descriptions of the Goose outputs in the chat implementation. So we're calling out to Anthropic, OpenAI, our local models. That gives you a tool call, and actually executing the tool is processed through either MCP or something like running a bash command and executing it, something on the command line. And then we capture that as the tool response and continue that loop. And this agent harness has become like increasingly simple and standardized over time. And so most of what happens in developing something like Goose is about making that extremely reliable, and then also supporting all of the different external tools that you might want to use. So it's not necessarily just about being a developer system, but also about connecting to the things that you use at work, the databases that you need to operate, the systems that you need to work with. And in something like Goose, we see a lot of people finding a way to use this to do work other than just programming. So that's a lot of examples of that are, reading through everything you have on Google Drive, helping you write emails and manage the way you work. And the MCP as the protocol for tool calling, I think is the right space to be in for when you want to work with an external system. So to give you, like Google Drive, for example. You want to be connecting online. It was maybe Google who implemented that MCP spec. You're doing it over HTTP. Increasingly, we're seeing it's easier to make those command line tools, like I was mentioning with Summarize, for when you want it to operate your computer or to be a developer system. And so you can kind of improve the quality you get by building these extremely well-contained, high-quality command line tools. And you get into this loop where the agent itself is helping you build those tools and extend its own capabilities and accelerating the way you're able to use the tool. Okay, so with that, let me send you a link to go see if you want to try out Goose yourself and run the agent. And this is our open source repo. There you'll also find a link to our Discord if you're interested in joining and talking to us about Goose.
All right. Thank you, Bradley. Do we have any questions?
Do you find that Goose is still effective in the way you described with already existing CLI tools that maybe aren't in Rust? Because, we didn't all write Rust forever. How has that been?
Yes, I think so Goose and the other agent harnesses, I think, do really well with any command line tool. And I think I glossed over in this discussion is that what you really want in those command line tools is that they always handle every error state, so that instead of like falling over in a way that is opaque, you return an error to the LLM so it can figure out what it needs to do next. And then the other thing you want at the end of the day is actually performance. So I think a lot of our developer tools, when I'm working with agents, it's no longer a single turn that produces code that I look at and then I run the tests. It's a loop where it keeps running the compiler and the tests until the entire process is working, and I come back an hour later. And so the speed of the tools that you're working with on the command line dictate a huge fraction of how long that loop actually takes these days. So you want that kind of combination. So I think we're in a spot where you want to actually compete on the quality of the command line again to make your agents more effective.
Oh, so when MCP came out, there were MCPs for things like file browser and crap like that. At least we've gone past that now. Can we extrapolate to a future where we don't have MCPs anymore and everything is CLI tools the way God intended it to be?
So I think that if you compare an MCV server implemented with standard I/O to a command line tool, it's the same, right? Like they're very literally or a collection of command line tools. They can do the same things. Where it really starts to matter is when you're building systems where you want to develop an agent that doesn't have full shell access on your computer, which it turns out is sometimes nice to have. So when we, for example, at Block, when we build customer-facing agents, we use MCP as an online spec to contain what it's able to do. But of course, if you're running something like Claude code with dangerously skipped permissions, it's great to just have it run through this command line. And as long as it's not asking you for permission at every step, this is like just as good and arguably more performant, I think.
Just curious if Goose would be something that could be potentially run via the web.
We yes, and in the Goose architecture, obviously we wrote most of the Goose code in web tech, so it's an Electron system. That's where it comes back to the it doesn't have access to running like a terminal on your computer. We do have some interesting things there for what it's worth. So there's a mobile experiment where you have Goose running and then you control it from your phone. And so it's almost like a Plex server or an architecture like that, where it's always running a daemon that you can interact with. And so that version also would work really well on web. But I think you also, like, if you want someone to use a web agent, you don't really expect it to have access to your local file system. And so even though you can make that happen, it's a little bit sketchy. And so I think a version of Goose on web would be really interesting to be powered by MCPs that work online, like interacting with your email, interacting with Google Docs, all of that content.
All right. Thank you, Bradley. Let's give a round of applause. Thank you. It's been a very long night, and thank you for sticking with us. We really appreciate you. Nick, can we put this slide over there? Okay, so we have a Discord server where you can talk to other people who participated in today's meetup, and then maybe you can reach out to us about given future talks. So please join it, and I just wanted to say thank you for joining us tonight, and thank you for enthusiasm. And yeah, we very much hope to see you at the future events. And I just wanted to say, again, big thank you to all the speakers, all the organizers, and then our sponsors, Block and Z Industries. And to you for making time, taking the trip, and yeah, being so enthusiastic about it, asking questions. I think Mikayla wanted to say something, no? Okay.
Also want to say thank you for being our master ceremonies. So, and thank you everybody for showing up.
Thank you, I appreciate it. Thanks, bye.